All right, boys and girls, welcome back to the drive-through for a little 6-bell edition. Hope everyone's having a wonderful day as we make our way through the last chapter of Algebra 1. This really reminds me of the Citivation Lab, this lesson. It's polling, it's taking people's opinion, trying to come up with a consensus. So this just makes me feel good about the fact that we're using this book in this space. All right, so if you haven't already done so, pause the video and read all of the scenario going on. And just to let you know, this part of the information has been copied over there because it will help us kind of describe the situation. So hopefully you've paused and done this. And this is a very typical way of presenting polled information. Here you've got soccer, dance, and total. Here you have girls, boys, and total. Okay, so obviously, if you add up the number of girls and boys, it'll add you to the total. If you add up the number of soccer and dance, it adds up to total. So just take a look at the table now, if you haven't already. So, how many total people were polled for this, Carson? Very good. 106 people were polled for this. Now, how many of them were girls? 60 of them were girls. So if I covered up the boys and told you that 106 were polled, how would you find out the number of boys? Subtraction. Good. So we know that these two things have to add to this. Okay? So let's just get on the same vocabulary here. Everything that you see in purple are called marginal frequencies, okay? So that's, is it defined there? So we're just going to consider the marginal frequencies to be the sums or the totals, okay? Whereas in the green highlights, those are going to be called joint frequencies. Okay, and those are partials. You've got girls, you've got boys, you've got people that like soccer, you've got people that like dance, and we can separate all those into different categories. Okay, now, it appears to me that in this polling, yes, they did ask, do they prefer? So you weren't allowed to put both. I'm sure we're going to get to a spot later where we're going to look at, what if we could have liked soccer and dance? And then you could throw out another variable. What would the other variable be? No, I mean, what if we had boys that like soccer, boys that like both, boys that like dance? What would be the fourth scenario in that? It would be boys that liked neither. Maybe someone didn't want soccer or dance. Maybe someone wanted soccer and dance. Well, all of those change the way we're going to calculate our answer and our probabilities, okay? So, using the data in the table, construct a viable argument and explain to Rashid which event he should choose. Well, this is really difficult. He has a very, very similar amount of soccer people as dance people. And if you look at the gender, if he picks soccer, what gender of people are going to be happy? It looks like the boys are going to be more happy. Only 14 girls wanted to play soccer. If he chooses to have a dance, then it looks like the boys aren't going to be very happy. Okay? So, construct a viable argument and explain to Rashid which after-school event he should choose. Well, I'm just gonna cop out here. Dear Rashid, thanks for reporting your data to me. In this case, I am going to advise you to offer both dance and soccer after school. I know this is not the answer we're looking for, but the data is nearly split 50-50 down the middle. In addition, I fear you may be alienating one of your groups. What are the groups? By choosing one way or another. A very Cinovation Lab type answer. Just don't answer the question. Do what you want. Okay? Moving on. So two-way frequency tables allow us to organize categorical data in order to draw conclusions. For each set of data, create a frequency table, and then write some observations. Look at any trends or associations. All right, let's read it carefully. There are 45 total students who like to read books. I think that's down here. Don't you? You tell me if you think I made a mistake. Of those students, 12 of them like nonfiction, and the rest like fiction. Let's get right to that answer. So this we're going to have to insinuate from the information. If all of them like reading books, and 12 of them like reading nonfiction, and 45 like reading books total, how can we find the amount of students that like fiction? Okay, sure. X plus 12 equals 45. How would we solve for X? Just like you said, we could just subtract 12, and you get, I think, 33 people prefer fiction. All right. 4 girls like nonfiction. Okay, so how many boys like nonfiction? Again, we did 12 minus 4, and we got 8. Excuse me, I'm going to change that color. Okay? 20 boys like fiction. All right, so how many boys in total like to read? That's a 0. Keep in mind, that's a 0. So 24 like to read. And 21 girls like to read. Okay, so now let's make some observations. Fiction is the most popular choice of book type. Great observation. Okay. Can we categorize the word more a little bit? More males prefer reading. More boys like reading. Is it a lot more? So we'll say slightly more boys. Let's use the verbiage from the study. Like to read books. Is that true worldwide, Carson?
No, just
in this data set. Excellent. Now, let's see. What else can we...
Girls in this data set mostly like fiction.
I think I would like to compare how the girls have more of an even split between fiction and nonfiction than boys do. You see that? It is very likely that a boy will prefer fiction, while it is only somewhat more likely that, Carson, a girl will have the same preference. So far, so good?
Yep.
All right. We're almost done. It's a quick video. All right. We're going to do a very similar thing here. 35 7th graders and 41 8th graders completed a survey. Okay, so now we got to fill in the headings. We've got more than an hour, less than an hour, 35 7th graders and 41 8th graders. What do you think goes in the vertical settings? We got 7th graders and we got 8th graders. Okay? 45 or 35 7th graders total, right? And 41 8th graders total, which brings our total amount of people surveyed to 76. All right, 50 students said they spent more than an hour. It doesn't say 50 8th graders or 50 7th graders, right? So this must be this. So then how many, well, I'll keep reading. 12 8th graders said they spend less than an hour. And so now we just have to do a whole bunch of subtraction. So let's find first how many total students did less than an hour. 76 minus 50 is 26. Well, if 26 people in total did less than an hour and 12 of them were 8th graders, then how many of them were 7th graders? How many? Nope. Nope. 26 minus 12? Oh, it is 24. No, 14. 14. Okay? So if 35... Oh, you're going to go to this one? So 29 8th graders studied for more than an hour. How many 7th graders? 21 7th graders studied for more than an hour. Okay? All right, let's make some observations now. You got one yet?
More eighth graders spend more time on their homework.
8th graders you think, is that true? 29, but you got 6 more 8th graders, but 8 more, I would agree, that is true. Okay? On average, 8th graders are more likely to spend over an hour on homework. Okay, next. How about just students in general? So almost twice as many students work more than an hour than what? Than do less than an hour. Do you agree with that? Just one away from being twice as many. You give me the next one.
There's more eighth graders surveyed.
I love it. There are more 8th graders than 7th graders. That's it.